Hello and welcome back to the Backend Masterclass. So far, we have learned a lot about working with database in Go. Now it's time to learn how to implement some RESTful HTTP APIs that will allow front-end client to interact with our banking service backend. Although we can use a standard net HTTP package to implement those APIs, it will be much easier to just take advantage of some existing web frameworks. Here are some of the most popular Golang web frameworks, together with their number of GitHub stars: Gin, BeGo, Echo, Revo, Martini, Fiber, and Buffalo. They offer a wide range number of features such as routing, parameter binding, validation, middleware, and some of them even have a built-in ORM. If you prefer a lightweight package with only routing feature, then here are some of the most popular HTTP routers for Golang: FastHTTP, GorillaMux, HTTP Router, and Chi. For this tutorial, I'm going to use the most popular framework, Gin. Let's open the browser and search for Golang Gin. Then open its GitHub page. Scroll down a bit and select installation. Now let's copy this go-get command and run it in the terminal to install the package. After this, in the go.mod file of our Simplebank project, we can see that Gin is added here as a new dependency, together with some other packages that it uses. Now I'm going to create a new folder called API, then create a new file server.go inside it. This is where we implement our HTTP API server. First, let's define a new server struct. This server will serve all HTTP requests for our banking service. It will have two fields. The first one is a db.store that we have implemented in the previous lectures. It will allow us to interact with the database when processing API requests from clients. The second field is a router of type gin.engine. This router will help us send each API request to the correct handler for processing. Now let's add a function new server. We take a db.store as input and return a server. This function will create a new server instance and set up all API routes for our service on that server. First, let's create a new server with the input store. Then we create a new router by calling gin.default. We will add route to this router in a moment. After this step, we will save this router object to server.router. Then return the server. Now let's go back here to add the first API route to create a new account. It's gonna use post method, so we call router.post. We must pass in a path for the route, which is /account in this case, and then one or multiple handler functions. If you pass in multiple functions, then the last one should be the real handler, and all other functions should be middlewares. For now, we don't have any middlewares, so I just pass in one handler, server.createAccount. This is a method of the server struct that we need to implement. The reason it needs to be a method of the server struct is because we have to get access to the store object in order to save new account to the database. I'm gonna implement this method in a new file, account.go, inside the API folder. So here we declare a function with a server pointer receiver. Its name is createAccount, and it should take a gin.context object as input. Why? Let's look at this post function. Here we can see that the handler function is declared as a function with a context input. Basically, when using Gin, everything we do inside the handler will involve this context object. It provides a lot of convenient method to read input parameters and write out the responses. Alright, now let's declare a new struct to store the createAccount request. It will have several fields, similar to the createAccount params that we used in the database. So I'm gonna copy these fields from account.sql.go file and paste them to our createAccount request struct. When a new account is created, its initial balance should always be 0. So I'm gonna remove this balance field. We only allow clients to specify the owner's name and the currency of the account. We're gonna get these input parameters from the body of the HTTP request, which is a JSON object. So I'm gonna keep these JSON tags. Now whenever we get input data from client, it's always a good idea to validate them. Because who knows, client might send some invalid data that we don't want to store in our database. Lucky for us, Gin uses a validator package internally to perform data validation automatically under the hood. For example, here we can use a binding tag to tell Gin that this field is required. And later, we call the should_by_JSON function to pass the input data from the HTTP request body. And Gin will validate the output object to make sure it satisfies the condition we specified in the binding tag. Okay, let's go back to our code. I'm going to add a binding required tag to the owner field. The currency field is also required. Moreover, let's say our bank only supports two types of currency for now, USD and Euro. So how can we tell Gin to check that for us? Let's open this documentation of the validator package and search for one of. Here we go. With this condition, we can tell Gin to check that the field should have one of the provided values. So let's copy this line and paste it to the currency binding tag. We use a comma to separate multiple conditions like this. And I'm going to change these possible values to USD and Euro separated by a space. Alright, now in the createAccount function, we declare a new request variable of type createAccountRequest. Then we call context.should_by_JSON function and pass in this request object. This function will return an error. If the error is not nil, then it means that the client has provided invalid data. So we should send a 400 bad request response to the client. To do that, we just call context.json function to send a JSON response. The first argument is a HTTP status code, which in this case should be http.status_bad_request. The second argument is the JSON object that we want to send to the client. Here we just want to send the error, so we will need a function to convert this error into a key value object, so that Gin can serialize it to JSON before returning to the client. We're gonna use this error response function a lot in our code later, and it can be used for other handlers as well, not just for account handlers. So I will implement it in the server.go file. This function will take an error as input, and it will return a Gin.h object, which is in fact just a shortcut for map string interface. So we can store whatever key value data that we want in it. For now, let's just return Gin.h with only one key, error, and its value is the error message. Later we might check the error type and convert it to a better format if we want. Now let's go back to the createAccount handler. In case the input data is valid, there will be no errors. So we just go ahead to insert a new account into the database. First we declare a createAccount params object, where owner is request.owner, currency is request.currency, and balance is 0. Then we call server.store.createAccount, pass in the input context and the argument. This function will return the created account and an error. If the error is not nil, then there must be some internal issue when trying to insert to the database. Thus, we will return a 500 internal server error status code to the client. We also reuse the error response function to send the error to the client, then return immediately. If no errors occur, then the account is successfully created. We just send a 200 OK status code and the created account object to the client. And that's it. The createAccount handler is done. Next, we have to add some more code to run the HTTP server. I'm gonna add a new start function to our server struct. This function will take an address as input and return an error. Its role is to run the HTTP server on the input address to start listening for API requests. Gin already provided a function in the router to perform this action. So all we need to do is calling server.router.run and pass in the server address. Note that the router field is private, so it cannot be accessed from outside of this API package. That's one of the reasons we have this public start function. For now, it has just one single command, but later we might want to add some gracefully shutdown logics in this function as well. Okay, now let's create an entry point for our server in the main.go file at the root of this repository. The package name should be main, and it should have a main function. In order to create a server, we need to connect to the database and create a store first. It's gonna be very similar to the code that we've written before in the main test.go file. So I'm gonna copy these constants for the DB driver and DB source, paste them to the top of our main.go file, then also copy this block of code that established connection to the database and paste it inside the main function. Let's change this testDB variable to connection and add a colon here because the variable was not declared before. Now with this connection, we can create a new store using db.newStore function. And we create a new server by calling api.newServer and pass in the store. To start the server, we just need to call server.start and pass in the server address. For now, I'm just gonna declare it as a constant, localhost port 8080. In the future, we will refactor the code to load all of these configurations from the environment variables or setting file. Okay, now in case some error occurs when starting the server, we just write a fatal log saying cannot start server. One last but very important thing we must do is to add a blank import for the libpq driver. Without this, our code would not be able to talk to the database. Alright, so now the main entry for our server is completed. Let's add a new make command to the make file to run it. I'm gonna call it make server, and it should execute this go run main.go command. Let's add this server command to the phony list. Then open the terminal and run make server. Voila, the server is up and running. It's listening and serving HTTP requests on port 8080. Now I'm gonna use Postman to test the create account API. Let's add a new request. Select post method. Fill in the URL, which is http:/localhost port 8080/account. The parameter should be sent via a JSON body. So let's select this body tab, choose raw, and select JSON format. We have to add two input fields, the owner's name, I will use my name here, and the currency, let's say USD. Okay, then click send. Yay, it's successful. We've got a 200 OK status code and the created account object. It has ID 1, balance 0, with the correct owner's name and currency. Now let's try to send some invalid data to see what will happen. I'm going to set both fields to empty string. And click send. This time we've got 400 bad requests and an error saying the fields are required. This error message looks quite hard to read because it combines two validation errors of the two fields together. This is something we might want to improve in the future. Next, I'm going to try to use an invalid currency code, such as XYZ. This time, we also get 400 bad requests, but the error message is different. It says the validation failed on the OneOf tag, which is exactly what we want, because in the code, we only allow two possible values for the currency, USD and Euro. It's really great how Jin has handled all the input binding and validation for us with just a few lines of code. It also prints out a nice form of request logs, which is very easy to read to human eyes. Alright, next we're gonna add an API to get a specific account by ID. It will be very similar to the create account API. So I will duplicate this statement. Here instead of post, we will use get method. And this path should include the ID of the account we want to get. Note that we have a colon before the ID. It's how we tell Jin that ID is a URI parameter. Then we have to implement a new getAccount handler on the server struct. Let's move to the account.go file to do so. I'm gonna copy this function signature and change its name to getAccount. Similar as before, we declare a new struct called getAccountRequest to store the input parameters. It will have an ID field of type int64. Now, since ID is a URI parameter, we cannot get it from the request body as before. Let's open the Jin documentation page and search for binding URI. As you can see here, we use the URI tag to tell Jin the name of the URI parameter. And we call the shouldBindURI function of the context to bind all URI parameters into the struct. Now get back to our code. Let's add the URI tag to this ID field. And also add a binding condition that this is a required field. Also, we don't want client to send an invalid ID, such as negative number. To tell Gene about this, we can use the mean condition. In this case, let's set mean equals to 1 because it's the smallest possible value of account ID. Okay, now in the getAccount handler, we will do similar as before. First, we declare a new request variable of type getAccountRequest. Then here, instead of should_by_JSON, we should call should_by_URI. If there's an error, we just return a 400 bad request status code. Otherwise, we call server.store.getAccount to get the account with the ID equals to request.id. This function will return an account and an error. If error is not nil, then there are two possible scenarios. The first one is some internal error when querying data from the database. In this case, we just return internal server error status code to the client. The second scenario is when the account with that specific input ID doesn't exist. In that case, the error we got should be a SQL.error no rows. So we just check it here, and if it's really the case, we simply send a file for not found status code to the client and return. If everything goes well and there's no error, we just return a 200 OK status code and the account to the client. And that's it, our getAccount API is completed. Let's restart the server and open Postman to test it. Let's copy this URL and add a new request. The method is get. Now we paste in the URL and add a /1 at the end because we want to get the account with ID 1. Let's click send. The request is successful and we've got a 200 OK status code together with the found account. This is exactly the account that we've created before. Now let's try to get an account that doesn't exist. I'm going to change this ID to 100 and click send again. This time we've got a file for not found status code and an error SQL no rows in result set. Exactly what we expected. Let's try one more time with a negative ID. Now we got a 400 bad request status code with an error message about the failed validation. Alright, so our getAccount API is working well. Next step, I'm going to show you how to implement a list account API with pagination. The number of accounts stored in our database can grow to a very big number over time. Therefore, we should not query and return all of them in a single API call. The idea of pagination is to divide the records into multiple pages of small size so that the client can retrieve only one page per API request. This API is a bit different because we will not get input parameters from request body or URI, but we will get them from query string instead. Here's an example of the request. We have a page ID param, which is the index number of the page we want to get, starting from page 1, and a page size param, which is the maximum number of records can be returned in one page. As you can see, the page ID and page size are added to the request URL after a question mark. That's why they're called query parameters and not URI parameter like account ID in the getAccount request. Okay, now let's go back to our code. I'm going to add a new root with the same get method. But this time the path should be /account only since we're going to get the parameters from the query. The handler's name should be list_account. Alright, let's open the account.go file to implement this function. It's very similar to the getAccount handler, so I'm going to duplicate it. Then change this struct name to list_account_request. This struct should store two parameters. The first one is page ID. Now note that we're not getting this param from URI, but from query string instead. So we cannot use this URI tag. Let's open the Gene documentation again and search for byte query. Here we can see that the form tag is used, and the function to parse and validate the input data is should_byte query. Let's go back to our code. I'm going to change this URI tag to form and update the parameter name to page ID. This parameter is required and the minimum page ID should be 1, so no need to change the binding conditions. Next, let's add one more field to store the page size parameter. In fact, both the page ID and page size can fit into 32-bit integer, so I'm going to change their data type to int32. Then update this field name to page size. For the binding condition, the page size parameter is also required. But let's say we don't want it to be too big or too small. So I'm going to set a minimum constraint of 5 records and maximum constraint of 10 records. Okay, now let's update this handler function name to listAccount and change this request type to listAccountRequest. Then here we should use another binding function, shouldByQuery, to tell Jin to get the data from query string. If an error occurs, we just return bad request status. Else, we call server.store.listAccount to query a page of account records from the database. This function requires the listAccount params as input. So let's declare this new argument variable. We have to provide values for two fields, limit and offset. Limit is simply the page size, while offset is the number of records that the database should skip. So we have to calculate it from the page ID and page size using this formula. Request.pageID minus 1 multiplied by request.pagesize. Okay, now let's pass this new argument variable into this listAccount function. If an error occurs, then we just need to return internal server error to the client. Otherwise, we send a 200 OK status code with the output accounts list. And that's it, the listAccount API is done. Let's restart the server. Then open Postman to test this request. It's successful, but we've got only one account in the list. That's because our database is quite empty at the moment. We just created only one single account. Let's run our database test that we've written in previous lectures to have more random data. Okay, now we should have a lot of accounts in our database. Let's resend this API request. Voila! Now the return list has exactly 5 accounts as expected. Account with ID 5 is not here because I think it's got deleted in the test. We've got account with ID 6 here instead. Let's try to get the second page. Cool. Now we get the next 5 accounts with ID from 7 to 11. How about the third page? This time we get the next 5 accounts with ID from 12 to 16. So it's working very well. I'm going to try one more time to get a page that doesn't exist. Let's say page 100. Okay, so now we've got a null response body. Although it's technically correct, I think it would be better if the server returns an empty list in this case. So let's do that. Here in the account.sql.go file that SQLC has generated for us, we can see that the account items variable is declared without being initialized. That's why it will remain null if no records are added. Lucky for us, in the latest release of SQLC, which is version 1.5.0, we have a new setting that will instruct SQLC to create an empty slice instead of null. Here we go, the setting is called emit empty slices, and its default value is false. If we set this value to true, then the result returned by a many query will be an empty slice. Okay, so now let's add this new setting to our sqlc.yaml file. Save it and open the terminal to upgrade SQLC to the latest version. If you are on a Mac and using Homebrew, just run brew upgrade SQLC like this. You can check your current version by running SQLC version. For me, it's already the latest version, 1.5.0. So now I'm gonna run make SQLC to regenerate the code. And back to Visual Studio Code. In the account.sql.go file, we can see that the items variable is now initialized at an empty slice. Cool. Let's restart the server and test it on Postman. Now when I send this request, we've got an empty list as expected. Now I'm going to try some invalid parameters. For example, let's change this page size to 20, which is bigger than the maximum constraint of 10. This time we've got 400 bad request status code, and an error saying the validation of page size failed on the max tag. Let's try one more time with page ID equals 0. Now we still got 400 bad request status. But the error is because page ID validation failed on the required tag. What happens here is, in the validator package, any 0 value will be recognized as missing. It's acceptable in this case because we don't want to have the 0 page anyway. If your API has a zero value parameter, then you need to pay attention to this. I recommend you to read the documentation of Validator package to learn more about it. Alright, so today we have learned how easy it is to implement RESTful HTTP APIs in Go using Gin. You can base on this tutorial to try implementing some more routes to update or delete accounts on your own. I leave that as a practice exercise for you. Thanks a lot for watching this video. Happy coding, and I will see you soon on the next lecture.